Alrighty, welcome to the video on analogous problems. You'll have to bear with me. I've been battling a little bit of a sore throat, so if you hear me kind of clearing my throat throughout this video, I apologize. Um, this right here is an example of a problem we've been working on in class. We have to find an algebraic expression for this. So it says 1/4 of Kevin's height. Now, an algebraic expression, all that is, we have a number, or a constant as we call it in class, a variable, which is like an unknown amount. So in this case, the unknown amount is Kevin's height. We don't know how tall he is. And also an operation. And the kids have been able to recognize that with this problem here, you're going to be doing division. So we'd have a division sign, but they've been confused about if it's k divided by 4, if it's 4 divided by k, or even if 1/4 should be the constant instead of 4. And so I hope that this example of using analogous numbers will help them out. What I tell them to do, one piece of advice, is to pretend Kevin is 8 feet tall. So he's not really 8 feet tall, but let's say he was. And so here's our friend Kevin. So he's really tall. This Kevin is actually really 7 feet tall. But 8's a good number to use because if we're dividing, we want it to come out even. It's just quicker to do in your head. So we're pretending he's 8 feet tall. And so we start with 8. And if we were to cut Kevin into fourths, and hopefully he doesn't need to have surgery or anything like that, we don't jinx him here, he would look something like this. So we would say, well, how much is each one of these little individual pieces worth? And if you do the math out, you'd say that each one of these individual pieces is worth 2. And so how did we get there? Well, we divided 8 into 4 pieces. And then I tell them to look back and say, all right, he's not really 8 feet tall. He's k feet tall, because this might not have been the Kevin we were talking about. It might have been a different Kevin. And so we replace 8 with k, but we're still going to be dividing, and the constant is still 4. That's an example of using analogous numbers, so using the number 8 and then turning that into k. This problem says how many more passengers can sit on 4 777 aircrafts than on 4 767 aircrafts. So one thing I want them to understand is what this means. How many more? What are they really asking? So it's okay to completely rename your problem so that you can understand the term how many more. So I'll say, well, how can you use the phrase how many more? And here's a good example of it. How many more hats does Derek have than Sam has? So Derek here, he has 7 hats, and Sam has 4. And from there, most students are able to recognize that Derek has 3 more hats, and we got that answer by doing subtraction. So then they know when we go back and look at this problem here, we're going to be doing subtraction. Now, the other problem they have is that the aircrafts are called numbers, and that's confusing as anything. So it's okay to pretend that your aircrafts are, whatever names you want to give them. So I gave them names of animals, and so I made the biggest animal have the most number of seats here. And, I kind of did it by that all the way down. I consider a lion to be bigger than a dog. And that will kind of make us see this a little bit better. So we replace the phrase in the problem with the word elephant and the word lion. So how many more passengers can sit on 4 elephant aircrafts? And there's 268 people on that. So we did subtraction here because as we proved before, how many more is going to be asking us for a subtraction problem. So 268 seats minus 250 seats, right? Because the elephant aircraft has 268. And if you want to go back to the original problem, there it is up there. And the lion has 250. So we subtract this. And when we do, we get 18 seats. But we're not done there because it says there are 4 of these aircrafts. So 4 elephants and 4 lions. So if that's the case, that means we were multiplying this whole thing at the beginning by 4. So we got to go off and multiply this by 4 times 18, and that would equal, if you do the math out, 72 seats. Alright, one more, and this is actually the challenge problem for this week. So this problem says simplify by combining like terms. Alright, so I'm going to simplify. I'd start maybe by doing the distributive property right here. So this is, well, I should change pens from red. This is 5c plus 15, and then the rest of it we can kind of tack on. And when it says like terms, those are terms that have the same variable with them, or if they don't have variables, like these are constants right here, 15 and 2, we'd combine those. So what I'm going to do is I'm going to group all the terms that are alike together. So I'm going to circle in blue all the ones with C, and that way we can tell the difference between them. So if I look at the C's, 7C plus 5C is 12C, plus 4C is 16C. And then this right here, there's no coefficient here. There's no number in front of the C. In that case, we just assume that this is a 1. So we would have, looks like 15C, because we're going to subtract that 1C. And then these two, 15 and 2, are also alike. So we have 15 minus 2, that would be plus 13. So we'd be left with 15C plus 13. And how can we use analogous numbers with this? I think what's confusing to people is that C isn't a real number. So if you wanted to plug in like a variable like 2, you could see if you get the same thing as we just got on that simplified problem. So remember that was 15C plus 13 we said the answer was. So let's say that C was the number, I don't know, we'll use the number 2. I don't like to use the number 1 because sometimes funny things happen with that. So if C was 2, this would be 14, 7C would be 14, plus 5 times, in parentheses, 2 plus 3. 4C would be 8, right? 4 times 2, minus 2, and then minus 2. If we do this out, this right here, this combines to be 5, and so we get 5 times 5. And then we can just kind of go from left to right here. So 14 and 25 is 39, plus 8 is 47, minus 2 would leave us with 43. Over here, if we just did 15 times 2, that would equal 30. And then plus the 13 would leave us with 43. So it does check out that this is actually a different way of writing this whole big thing here. So I hope this video on analogous numbers helped you out. I know you might be thinking, well, these problems, they take a lot of time. It's really involved. And you're right. And if your child had, if they tried to use analogous numbers on homework problems and it felt like they were taking a really long time, it's okay if they skip a couple of problems. You can actually sign their papers and say, my child was working for 30 or 40 minutes or whatever. And if they don't finish and I see your note, then I'll acknowledge that they did the homework assignment. And I really want them to do the problems as thoroughly as they can. And this is absolutely doing that.